Hey guys, it's Stephen Gates here from myplctraining.com, and I've got another video for you today to help you become a confident PLC programmer and automation pro. This video is about analog and discrete I/O, and specifically I/O modules and how to use them in Studio 5000 Logix Designer. So we're not going to go into great detail about how discrete and analog I/O work in this video, but I just want to give you a quick summary here before we get started. So discrete or digital is another name for it. I/O is either on or off. So think of a light switch where the light is either on or off or on, whichever. And then analog I/O would be more like a dimmer switch, where you can adjust the brightness of the lights up and down. So all the way up it's fully bright, and then you slowly dim it until it's off. So that would be something comparable to analog I/O. So just to clarify, when I say I/O, I'm talking about inputs and outputs. I for input, O for output. So the discrete and analog inputs will be devices that are external to the PLC, and they're wired into the PLC to tell it status or position of a machine, or take a control selection from an operator, like when they push a button or turn a switch, tells the PLC what's going on. And outputs, whether it's discrete or analog, those are the devices and or machines that are being controlled by the PLC. So in a plant or factory environment, the discrete inputs would be things like push buttons, like we said earlier, relay contacts that are connected to the PLC, and discrete outputs would be things like motor starter relays, where the PLC is telling the motor to start, alarm lights, or other things that are on or off, and those again are being controlled by the PLC. Analog inputs would be things like tank level sensors, so how full the tank is, that are connected to the PLC. And analog outputs would be things like control valves or variable frequency drives controlled by the PLC. So control valves would be a valve where the PLC can open it a certain amount, open it all the way, close it all the way, open it 50%, so on. Variable frequency drives would be something where you're adjusting the speed of a motor through a drive. Okay, so that's a quick summary of analog and discrete digital I/O, the differences. So we are going to get into the software now. So here we are in Studio 5000 Logix Designer, and I've got a project created already with a Compact Logix 5069 L310ER controller. Okay, so the first thing we're going to do is we're just going to add 4 I/O modules to our project here. So we go to the I/O configuration here. In the controller organizer, we find the back plane, right click, click new module. And first we're going to add a discrete input module. There we go. And so we can use this filter section to help us find what we want. So I'm going to uncheck that and then click digital. So again, digital and discrete I/O is the same thing. Now we have some options here. As you can see, there's several modules. We're going to choose an input module to start with. So I'm just going to choose the first one available here. So the part number for an input module will almost always have an I in it. So this is a 16.79 volt to 264 volt AC input. So I'm just going to double click that. And no need to give it a name. When this new module properties comes up, we can just hit OK. Okay, next we want to add a discrete output module. So we will leave the filter set on digital because this is a discrete or digital output. And we're going to look for modules with the letter O in the part number or the catalog number. So we have several here. Let's say we want an output module that uses AC voltage as well, so our input input module uses AC voltage. Let's get an output module that does as well. We'll go for the OA16. Double click. No need to name it. Just hit OK. Okay, next we're going to add an analog module. So we'll do an analog input module to start with. As you can see, there's not as many analog I/O options, just because there's not as much demand for different types of analog I/O. So we will choose this first one, which is an 8-channel voltage or current analog input module. So double click. Hit OK. And lastly, we are going to choose an analog output module. Double click. The OF4 is a 4-channel analog output module. Click OK. And then we're going to close this. Okay, now our I/O configuration should look like this. We've got our controller in slot 0, the IA16 input module in slot 1, the OA16 in slot 2, the IF8 in slot 3, and the OF4 in slot 4. So now let's see how we can use these I/O points in our logic. So we are going to go to the main program. So this is the default program in a new project when you create a project in Logix Designer. So open the main program and open the main routine. And I'm going to delete that because we're going to create it from scratch. So for the sake of time, we're going to be adding the simplest logic possible. So on rung 0, we are going to add an XIC, this guy here, and an OTE. So for the XIC, we want to address this to our discrete input module, or digital input module. So if you double click this question mark, and then click the pull down menu here, you can see what addresses are available from our I/O modules. So our discrete input module is the IA16 over here, which is in slot 1 again. So if we go to local :1:I, I is for input, so 1 for slot 1, I for input, expand that, and there's different options here, but we want to find something specific. So just a quick note that the syntax for addressing I/O modules varies from module to module. So you may need to look in the manual for a particular module if you're unsure of how to address its points. So just do a Google search for whichever module that you're working with. So usually the catalog number is a good place to start. So if, in this case, it would just be 5069 IA16. You could put Allen Bradley too if you like, but generally the instruction manual or user manual or something should come up, and you should be able to find out what the proper syntax is for addressing it. But a lot of times you can just figure it out by scrolling through and seeing what's available. So like I said before, if it's an input module, it's going to have an I somewhere in it, and then that number corresponds to the slot number of the module in the rack. So I happen to know the syntax, proper syntax for this module is local :1:I dot 0.00. So there's 16 points, and so this is our 0th point. So if we just expand that guy, then we have some more options. We want the data. Okay? So almost always you're going to be referencing the data member of a tag for whichever I/O point you're addressing to. Okay, finally we got it. Alright, so then that's coming from our input module, and this is going to drive an output. So in the output case, our discrete output module is slot 2. So pull this down, local 2, and we want O this time for output. And we are going to use 0.0 on this. We could use 0.1 or 2, whatever, but we're going to use 0.0. Expand that, and again, it'll be data. So you can see the format looks really similar for these. This one just has a 1 and an I, and this one has a 2 and an O. Okay, so that looks good. Let's add a second rung here. And on this rung, we will put an LES instruction. And this is a less than instruction. So you use this when you want to compare a value to another value. So you can take a tag and compare it to a fixed value, or you can compare one tag to another tag. And just a quick note, the logic I'm created is not recommended for anything in real life. This is just an example to show you how to address I/O modules directly in your logic. So we'll put our less than instruction there, and then on the right we are going to put an add instruction. Come on, there we go. So in our LES instruction, our less than, we're going to put the address of one of our analog input points or channels. Our analog input module is in slot 3. So if we pull this down, scroll down to local 3, expand that, and this one's going to look a little different. So instead of 0.00, it's going to be channel 00. So it's similar. Then we'll expand that, channel 00, and we're looking for data. Very good. So it's similar to that one, except instead of PT, we've got CH for channel. And let's say we're comparing this to the number 10 for the sake of this example. And next we're going to control and vary an analog output based on this LES instruction. So if we go over to our add instruction, we're going to use channel 3, so we're going to use the destination of the add instruction. And again, I'm not going to get into the details of how to use an add instruction. That's for another video, another time. But the destination is what we're focused on. That's what's going to control the output in this case. So slot 4 is our analog output module, the OF4. Expand the 4:0. And in this case, instead of just using channel 0, we're going to use channel 3 just to do something different. So expand that, and then scroll down to channel 3.data. And for the add instruction, we will say that we're going to add 5 to the input. So I'm going to take this guy, copy it, put it here in the source A. And so we're saying if the analog input is less than 10, we're going to add 5 to it and put it into the analog output. Again, this is not recommended for anything. It's just a demonstration of how to use your I/O modules and how to address it appropriately. Okay, so that wraps up this video. Hope you found it helpful, and hopefully you have a good idea of how to use analog and discrete I/O modules in Logix Designer, Studio 5000, and how to address those points in your ladder logic. Obviously, there's probably a lot of gaps for you if you are new to PLCs. This may have brought up more questions than answers. And if that's the case and you're looking for more help with learning PLCs and becoming a competent PLC programmer, check out My PLC Training Academy. That's the membership that we've created for automation training to help electricians, technicians, and engineers become confident PLC programmers. So hope this video is helpful. If you need more help, check out the Academy, and I'll see you in the next video.